Welcome to my channel, dear students. So today we are going to start a new topic, that is second order derivative. Now second order derivative means we are differentiating the derivative of a function. Okay, suppose if there is a function y equals to fx, then the derivative of this is dy by dx. Yes or no? So if I find the derivative of dy by dx again, then that is known as second order derivative, and this is written in this format. Okay, and not only this format, there are many other notations as well. So one notation is here, another is y double dash, another is f double dash, another is y2, another is d squared y. Okay, so all this represents your second order derivative. Now we'll see how to find second order derivative of the given functions. So in the first question it is asked, find d square y by dx square, that is second order derivative, when y is equals to this much. So first is you need to find dy by dx, and here what we need to do, we need to apply chain rule. Yes or no? So let's apply chain rule out there. So differentiating, so you'll write that by yourself. So we have dy by dx. Now the chain rule says first differentiate log. So when I differentiate log, then I'll get 1 by sine x into, now the differentiation of sine is cos x. Yes, so that means my dy by dx is cos x by sine x, that is cot x. Is that clear? Now differentiating again both sides with respect to x, then this can be written as d by dx of dy by dx, and here it becomes d by dx of cot x. Okay, so differentiation, that is d by dx of dy by dx is d square y by dx square, right, is equals to, now differentiation of cot. So it starts with c, so that's why it should be negative. So differentiation of cot will be cos x square x. Okay, so my answer is cos x square minus cos x square x. Pause the video to note down. Okay, so the next problem is we need to find second order derivative of this function. Okay, so I hope you know what is the derivative of a to the power x. It is how much? It is a to the power x, dy by dx will be a to the power x log a with base e, right? Okay, now since this is in this format, this function is given in this format, so that's why derivative of this will be equals to a to the power x. So a to the power x, that is 2 minus 3x. So log e with base e with number a is 10 here. Now this is above, this is for your a to the power x, but we need to differentiate the power as well. So power is 2 minus 3x. So differentiation of 2 is 0, and differentiation of minus 3x is minus 3. So this can be written as 0 minus 3 is minus 3, and this is also constant, so that's why let me write this in the front. So we have into 10 to the power 2 minus 3x. Okay, now we need to find second order derivative, so we'll differentiate again. So differentiating both sides with respect to x, so this becomes d square y by dx square. Yes or no? Okay, so since this quantity is constant, so that's why I can write this outside. So we have, okay, now we need to differentiate this. So differentiating this means this, right? So both are same, so that's why when I differentiated this, I got this thing, right? So that's why I'll again write the same thing, minus 3x. Okay, that is minus into minus plus 3 into 3 is 9. So log this both means both gives me log 10 with base e whole square, and here we have got 10 to the power 2 minus 3x. So this will be our answer. So pause the video to note down. Okay, let's see the next problem. So y is given to be tan inverse of sec x plus tan x. So we need to find second order derivative at x equals to pi by 4. So first let's find this one. So we'll differentiate both sides with respect to x. So differentiating both sides with respect to x, both sides with respect to x, then I'll get dy by dx equals to, now let me call this to be x. So differentiation of tan inverse x will be 1 by 1 plus x square. And what is x? X is sec x plus tan x. Okay, now we'll apply chain rule, so that's why there's multiplication sign here. Now we need to differentiate sec x plus tan x. Now what is differentiation of sec x? It is sec x tan x plus, what is differentiation of tan x? It is sec square x. Okay, so that's why my dy by dx, from here my dy by dx will be, so you can take out sec x as common, so sec x is common, so we have tan x plus sec x by 1 plus, this is sec x plus tan x whole square. Now let me apply a plus b whole square formula out there. So if I do that, then in the numerator it will be sec x into tan x plus sec x. It remains as it is. So let me apply a plus b whole square formula. 1 is already there, so a square is sec square x plus 2ab plus b square. B square is tan square x. Now we know that sec square theta can be written as 1 plus tan square theta. Okay, so instead of this and this, I'll write sec square x. Okay, and that sec square x along with this sec square x becomes 2 sec square x. Okay, so I have dy by dx is equals to, numerator is as it is, sec x into tan x plus sec x. So in the denominator we get 2 sec square x. Okay, so 1 plus tan square x is sec square x, and along with this it is 2 sec square x plus 2 sec x tan x. Okay, so we have got something common, so let me take out that common. So we have numerator as it is, sec x into tan x plus sec x. Now here we have got 2 sec x as common, so from here sec x is left, and from here only tan x is left. Okay, so sec x and sec x is cancelled, so this and this also gets cancelled. So what is left? So dy by dx is going to be how much? It is just half. Okay, now we need to find second order derivative, so that's why I'll differentiate it again. So differentiating both sides with respect to x. Okay, because dx square is there, so that's why I'm differentiating with respect to x. So we'll get here in the left hand side d square y by dx square, and differentiation of half is going to be 0, right? So I found my d square y by dx square to be 0. So for any value of x, my second order derivative is going to be 0. Okay, similarly for any value of x it is 0, that's why x at x equals to pi by 4 also dy by dx second order derivative will be 0. Okay, so d square y by dx squared at x equals to pi by 4 is also 0. Okay, so this is our answer. So pause the video to note down. Okay, so in this question we need to find y2. Y2 also gives me the second order derivative. So y2 and d square y by dx square both means the same. So we need to find y2 in each of the following cases. So the first one is this equation. So x is given separately, y is given separately. That's why it has to be parametric differentiation. Okay, so we'll first find y2, we'll first find the first order derivative, and we are already aware of finding first order derivative. Okay, so let me call this as 1, let me call this as 2. Okay, two equations are given, So here if you see the parameter is theta. Okay, a is a constant, so that's why we'll first differentiate 1 and 2 with respect to the parameter, that is theta. Okay, so differentiating 1 with respect to theta, let's see what do we get. So I'll get dx by d theta is equal to, so a is a constant, so it will be kept outside, so differentiation of theta with respect to theta will be 1 plus differentiation of sine theta with respect to theta will be cos theta. Okay, now we similarly will differentiate 2, so differentiating 2 with respect to theta, then I'll get dy by d theta equals to, a is constant, so that's why it will be kept outside, so differentiation of 1 is 0 minus differentiation of cos theta will be minus sine theta, so along with this minus it becomes plus, so it will be sine theta, so this is actually a sine theta. Okay, so we got dx by d theta, we got dy by d theta. Then we are ready to find the first order derivative, that is dy by dx, and that will be equals to dy by dx will be equals to dy by d theta, yes, into d theta by dx. Yes, okay, so that's why we have dy by d theta is a sine theta. Okay, so or you can write this as divided by dx by d theta as well. So divided by dx by d theta is a into 1 plus cos theta. So a and a gets cancelled, so I'll get sine theta by 1 plus cos theta. Okay, so this is our first order derivative, but we want to find the second order derivative, that is d square y by dx square. Okay, so we'll differentiate it again, so differentiating both sides with respect to x, because we want to find d square y by dx square. So I'll get d square y by dx square in the left hand side, and in the right hand side I'll have d by dx of sine theta by 1 plus cos theta. Now if you see here carefully, here we have got theta, this full thing is a function of theta, and you are differentiating it with respect to x. Okay, so we'll try to balance this, we'll try to make it theta. So if I keep it as theta, d by d theta, then I need to do some manipulation, and that manipulation looks somewhat like this. So I'm going to put d theta by dx out there, so that we can remove d theta and d theta, and ultimately I'll get d by dx. Okay, so this is how we manipulate. Hope this is clear to you. Now next is, this is f by g form. So f by g form is differentiated in this way, so denominator square, so denominator will be kept as it is, we will differentiate the numerator, and differentiation of numerator is cos theta minus, now the numerator remains as it is, sine theta, and we'll differentiate the denominator, that is differentiation of 1 will be 0 and differentiation of cos theta will be minus sine theta. Okay, so this much is the value for this one. Now this into sine into, and d theta by dx is the opposite of this, that is 1 by a into 1 plus cos theta. Hope this is clear to you. Now let's open the bracket. So we have cos theta into 1 is cos theta, plus cos theta into cos theta is cos square theta. Similarly this is minus into minus is plus, so sin theta into sin theta is sin square theta by 1 plus cos theta whole square into 1 plus cos theta is whole cube, and this a is written out there. Okay, and what is the value of sin square theta plus cos square theta? This full thing is equals to 1. This whole thing is equals to 1. So we have got 1 plus cos theta, and here also we have got 1 plus cos theta, so that and that gets cancelled, so I'll have in the numerator only 1 left, and in the denominator we have got 1 plus cos theta whole square. Okay, 1 plus cos theta gets cancelled with the numerator 1, so this will be the second order derivative. So pause the video to note down. Okay, so next is we want to find the second order derivative of this one. So this is again parametric equation. Okay, so let me call this to be equation 1 and let me call this to be equation 2. Okay, so let's differentiate 1 with respect to t. So differentiating 1 with respect to t gives me dx by dt equals to differentiation of e to the power t is e to the power t itself. Similarly, I'll find first order derivative of y. So differentiating number 2 with respect to t. So this gives me dy by dt equals to differentiation of sine t is cos t. Okay, so that's why therefore dy by dx can be written as dy by dt by dx by dt, which is dy by dt is cos t by dx by dt is how much? It is e to the power t. So this is my first order derivative. Okay, so next is we will differentiate both sides with respect to, now since our aim is to find d square y by dx square, so I need to differentiate with respect to x. Okay, so here in the left hand side I'll get d square y by dx square equals to, in the right hand side I have d by dx of cos t by e to the power t. But since this is a function of t, instead of writing x here, I'll do some manipulation. Here I have got t, so I'll put t here and I'll do this manipulation out there. Okay, hope this is clear to you using the earlier problem. Okay, now this is f by g form, which is again the same kind of form. So the form says denominator square, so denominator is kept as it is, we'll differentiate the numerator. So numerator is cos t, the differentiation of cos t is minus sine t, and we'll write minus, so cos t will be kept as it is, and now we'll differentiate the denominator, that is e to the power t, and differentiation of e to the power t will remain as it is. Okay, now into dt by dx. And what is dt by dx? So from here dt by dx is going to be 1 by e to the power t. Hope this is clear to you. Now in the numerator we can write minus e to the power t as common. So if I do that, then I have sine t plus cos t here. Okay, by here we have got e to the power t square, right? And including this, I will get e to the power t cube. Okay, so one of them gets cancelled, so ultimately I am getting minus sine t plus cos t by e to the power t whole square, which is e to the power 2t. Okay, but we need to find the second order derivative at t equals to pi by 4, pi by 2. So therefore d square y by dx square at t equals to pi by 2 becomes, let's see how much it becomes, minus sine, okay, so wherever t is there I'll put pi by 2, so it will be pi by 2 plus cos pi by 2 plus divided by e to the power 2 into pi by 2. So pi by 2 and pi by 2 gets cancelled, equals to minus, now sine pi by 2, that is sine 90 is 1 and cos 90 is 0. So that's why in the numerator I have this much, and in the denominator what is left? E to the power pi. So it can be written as minus e to the power minus pi. So my answer is minus e to the power minus pi. So pause the video to note down. Okay, so next problem is, if sin x is given to be 2 tan theta by this one, and similarly cot y is given to be this much, so we need to find dy by, we need to find d square y by dx square. So as usual, since this is parametric, I'm going to call this as 1. I'm going to call this to be 2. Okay, now from here I need to calculate dx by d theta, because here I have got x and here I have got theta. Parameter is theta, so that's why I'll first find dx by d theta. Similarly, from here I'll find dy by d theta. Now let's check whether these can be simplified further or not. Okay, so from here I have sine x equals to 1 plus tan square theta is how much? Sec square theta, right? So 2, now this tan theta I am writing this as sine theta by cos theta, and 1 plus tan square theta is sec square theta. Okay, now we know that cos theta into sec theta is how much? 1. So only sec theta is left from here. Is that clear? So if only sec theta is left, then we have sine x equals to 2 sine theta by sec theta, and the sec theta, when it goes up, then I'll get cos theta. Hope you are understanding. Okay, now next is, so you can write, since cos theta sec theta is 1. Okay, now sine x is equals to 2 sine theta cos theta is how much? It is sine 2 theta. So that means from here what do I get? I get x to be 2 theta. Okay, so let me call this to be equation 3. Now let me make use of equation 2. So this, when I invert it, suppose if I find the reciprocal of this, then this becomes 1 by cot, which is tan y. Yes, and this in turn is equals to 2 tan theta by 1 minus tan squared theta. Okay, now from class 11 trigonometry, using multiple angles, this is equals to tan 2 theta. So there's a direct formula here. So similarly from here, y is equals to how much? 2 theta. So let me call this to be equation 4. Okay, so from here I'm going to find dx by d theta, and from here I'm going to find dy by d theta. Okay, so therefore dx by d theta, that means if I differentiate 3, then I'll get differentiation of theta will be 1, this 2 will be left. Okay, so dx by d theta is 2. Similarly from here dy by d theta is going to be 2. Okay, so therefore dy by dx, that is first order derivative, is dy by d theta divided by dx by d theta. Okay, so what is dy by d theta? It is 2 by, what is dx by d theta? It is again 2. So 2 by 2 is 1. So my dy by dx is how much? 1. Now we need to again differentiate, right? So differentiating with respect to, since we are finding dx square, so we have to differentiate with respect to x. So here this becomes d square y by dx square, and the derivative of 1 is going to be 0. So that's why my answer will be 0. So pause the video to note down. Okay, so dear students, now we'll see the next problem, that is this one. So if y is this much, we need to prove this one. So y1 stands for the first order derivative and y2 stands for the second order derivative. Okay, so let's begin. So we have y equals to this one, and this can be further simplified in this way. So x cube log, now this x 1 by x can be written as x to the power minus 1. Yes, and this power can be taken in front, so this can be written as, from here, y equals to, so if this minus 1 comes from, then I can write this as minus x cube log x. Okay, now let's find y1, the first order derivative. Okay, so from here, if I differentiate both sides with respect to x, then I get y1, the first order derivative, in the left hand side. So in the right hand side I've got f into g format. So if I have that, then I'll keep one as it is, and I'll differentiate the other one, that is differentiation of log x 1 by x, plus now log x will be kept as it is, and differentiation of x cube will be 3x squared. Okay, so this and this gets cancelled. So from here I can write x square as common, right? So if I write x square as common, so I have minus x square into, from here I have got 1, plus from here we have got 3 log x. Okay, so this is my y1. Now let us find what is my y2. So to find y2 I need to differentiate the first order derivative. So differentiating again, so I'll get y2 equals to, so minus is there, so again this is my f and this full thing is my g, so f into g is there. So let me write f as it is and let me differentiate this one. So differentiation of 1 will be 0 and differentiation of this will be 3 by x. Okay, so plus, now this will remain as it is, so 1 plus 3 log x will remain as it is and we'll differentiate x square. This will be 2x. Okay, so simplify. Okay, so this is 3 by x, so this full quantity is 3 by x and x square and x gets cancelled, so only x is left. So this full thing gives me 3x. Okay, so let me open the bracket. So we have 2x into 1 is 2x plus 2 into 3 is 6x log x. Okay, so ultimately I'll get minus, okay, so this plus this is 5x plus 6x log x. Okay, so this is my y2. Now we need to prove this, so that's why let me take left hand side. So left hand side contains x into y2 minus 2y1 plus 3x square. So let's put the values. So x into y2 is how much? Minus this much, right? So minus 5x plus 6x log x minus 2y1. So y1 is this much, so minus into this minus becomes plus, so plus 2 and y1 is this one, so x square into 1 plus 3 log x, so plus 3x square is there. So let us simplify this. So open the bracket, so minus 5x square minus into plus minus 6x square log x. Yes, so similarly we have 2x square plus 2 into 3 6x square log x plus 3x square. So here this and this gets cancelled, right? So we have minus 5x square, this and this gives me plus 5x square. So again both gets cancelled, so ultimately I'll get 0, which is my right hand side. So pause the video to note that. Now we'll see this problem. Y is given to be this much, we need to find. Okay, so let's try to understand what is the meaning of this. This means y2 means second order derivative, and this 0 means you need to find the value of second order derivative at x equals to 0. Since the independent variable here is x, so this 0 is the value of this independent variable, that is x. Okay, so first we'll find y1 in order to find y2. So from here y1 will be equals to, we'll make use of chain rule, so differentiating with respect to x. So here in the left hand side I'll get y1, and differentiation of e to the power x will be e to the power x itself, so e to the power x itself into, now we need to differentiate the power, so differentiation of m, this is a constant, so it will be kept outside. Now differentiation of sine inverse will be 1 minus x squared. Yes or no? So this can be written as m e to the power m sine inverse x by root over 1 minus x squared. So this is my first order derivative, but we are interested in finding second order derivative, so that's why differentiating again, so you'll get y2, so m is constant, so it will be kept outside. So this is my f and this is my g, so it is f by g format. So f by g format gives me denominator square, that is g square, so 1 minus x square whole square. So this is my denominator square. Now denominator will be kept as it is, and we need to differentiate the numerator, that is e to the power m sine inverse x. And just now we saw that the differentiation of e to the power m sine inverse x is going to be this full quantity, right? So I have m e to the power m sine inverse x by 1 minus x square. Okay, so this is differentiation of numerator minus, now this numerator remains as it is, that is e to the power m sine inverse x, and we need to differentiate root over 1 minus x square. So if I differentiate root over 1 minus x square, let's see how much do I get. So here the power is half, so that's why this power comes in front. So I have x square half minus 1 into, now we'll differentiate the inner part, and it will be minus 2x. It will go, for 1 it is 0, and for minus x square it is minus 2x. So 2 and 2 gets cancelled, so this is equals to minus x. Okay, in the numerator we have got x, and this is to the power minus half. So to the power minus half can be written as, when it goes to denominator it becomes square root, so I have this much. Okay, so this is the differentiation of this one. So instead of this I can write minus x by root over 1 minus x square. Okay, so let me simplify this further. So this and this gets cancelled, right? So minus into minus becomes plus, and here also I have got this one, because square root and this can be removed. So I have in the numerator, okay, so e to the power m sine inverse x is common, so m is there, so e to the power m sine inverse x is common. Okay, now what is left from here? Only m is left. Okay, now from here minus into minus becomes plus, this is already gone outside, so we have got x by root over 1 minus x square. Okay, so this is the value of my y2. Okay, so if you want to simplify this, you can simplify it further, but our aim is to find y2 at x equals to 0. Okay, so therefore y2 at x equals to 0 is going to be, okay, so wherever x is there I'll put 0. So I have m into, so m plus 0 by root over 1 minus 0 square by 1 minus 0 square into e to the power m sine inverse 0. Okay, simplify this. So we have m, so this quantity is 0, yes, so 0 by anything is 0, so it will be m plus 0 is m itself, so 1 minus 0 square is again 1. Now e to the power m into, now sine inverse 0 is how much? Sine inverse 0 is, it is 0, so e to the power m into 0. Now m into 0 is also 0, so e to the power 0 is again 1, right? So 1 into m into m, this m by 1 is m, so that's why it's going to be m into m is square, and e to the power 0 is 1, so that's why my answer is going to be m square. So pause the video to note down. Now we'll see this question. So in this question, given is this one, so we need to prove this much. So basically what we are going to find is, we'll find d square y by dx square, that is second order derivative of y. Okay, so let's see what is y from here. So from here y is equals to cos x by cos a plus x. Okay, so we'll first differentiate it with respect to x in order to get first order derivative. So from here, if I differentiate both sides with respect to x, I'll get dy by dx, and since this is f by g form, that's why we have denominator is squared, right? Denominator will be kept as it is. We'll differentiate numerator, so differentiation of cos x is minus sine x, so minus sign is there, right? Now we'll keep numerator as it is, and we'll differentiate denominator, and the derivative of denominator, that is cos a plus x, will be minus sine of a plus x. Okay, so let us simplify this. So minus into minus plus. Okay, here I've got plus, so plus into minus becomes minus. So let me write this term first. So if I write this, then I have sine a plus x cos x minus cos a plus x into sin x by cos square a plus x, right? Now this is in a formula. Okay, this is kept in a formula. Sine a cos b minus cos a sin b, which is sine a minus b. So this can be written as sine a is a plus x minus b is x. Okay, divided by cos square a plus x. So this and this gets cancelled. So I can write this as, I have got only sine a here, and this cos square, when it goes up or when it goes to the numerator, then I will get sec square a plus x. Okay, so this is my first order derivative. Now differentiating again with respect to x. So in the left hand side I am going to get d square y by dx squared. Okay, now sine a, since this does not contain any x, so that's why it has to be a constant, so it will be kept outside. So we need to differentiate only sec square a plus x. So since there is a power, we'll first differentiate for power. So it is like x square, and differentiation of x square will be 2x. So 2 into x. And what is x? X is the base, that is sec a plus x. Okay, so we have differentiated the power. Now according to chain rule, we need to now differentiate sec, and the differentiation of sec is sec x tan x. So sec x is a plus x, tan x is this much. Now according to chain rule, we need to differentiate this as well. Now differentiation of a will be 0 plus differentiation of x will be 1. Okay, now if you multiply this, you have 2 sine a, you have got sec a plus x, so that's why together it is sec square a plus x, and what is left? Tan a plus x is left. So that's what I need to prove here. Okay, so we have proved it. So please pause the video to note down. Thank you very much.